In this training tutorial, I will run through the whole process about how to set up Modbus serial communications between CP2E PLC and 3G3MX2 drive. You will learn quite many things like how to set up PLC, utilizing Modbus RTU function blocks, how to set up serial option board, how to set up 3G3MX2 Modbus parameters and so on. So let's get started. Required software: CX Programmer 9.7 or higher, CX Driver 3.0 or higher. Of course, if you are good at 3G3MX2 VSD settings, you can also utilize the keypad to input all of the settings. Important: it is necessary to use the new version of CX Programmer. The old version of CX Programmer doesn't support CP2E series PLCs. CP2E Modbus RTU communications setup. As you might have known, CP1L and CP2E both support the simple Modbus RTU master function. So in this example, we just utilize this function to implement the Modbus RTU communications from PLC to 3G3MX2 VSDs. Obviously, PLC is taking the master role, MX2 VSD as the slave device. We use the CP1WCIF11 option board on the PLC and using RS485 two wires to link slave devices VSD together. To eliminate the noise from the network, it is necessary to set up a terminating resistor at the first node and the last node device. If the last node on the Modbus network is Omron 3G3MX2 VSD, you can just simply turn on the terminating resistor on the VSD, no need extra resistor. Please be aware that CP2E is quite different than CP1L. For example, CP2E W memory area is from W0 to W127, but CP1L W memory area is from W0 to W511. Also, lots of differences on PLC instructions, so on CP2E Modbus RTU communications, you can't use existing or old CP1L function blocks. For CP2E, you must use new designed Modbus RTU function blocks. You can either use CP1W series option boards or CP2W series option boards to implement the Modbus RTU communications. It is up to your application. In this example, I chose CP1WCIF11 to carry out the communications. Please be aware that both EP1W series and CP2W series option boards cannot be used on NX1P2 PLC, both are only designed for C-series micro PLCs. Please note: new CP2W series option board, it does support 2 channels Modbus communications on port 1 port, so it is important to use the correct function blocks to implement the Modbus communications. New CP2W series option board can only be mounted on port 1, not port 2, please be aware of it. In this example, I chose the common option board CP1WCIF11 to do the testing. CP1WCIF11 is non-isolation model, the communications distance is 50 meters in maximum. CP1WCIF12 is isolated model, the communications distance can reach to 500 meters in maximum. Of course CIF12 is more expansive than CIF11 option board. The wiring diagram is quite straightforward, just using 2 wires RS485 link master device and slave devices together. Heads up: it is necessary to set up CP1WCIF11 dip switches, otherwise the communications will not go ahead. You will keep getting 0080 and 8088 error code in function blocks. So in this example, we set all pin dip switches on except pin 4 off. You can either use RDA RDB plus or SDA SDB plus. The reason I chose SDA and SDB because frame grounding FG is just next to them, it is bit easier to do the wiring. As you might have known, RS485 serial communications only needs 2 wires to implement the communications. Only RS422 needs 4 wires to implement the communications. Of course, if you want, you can definitely connect multiple devices on the same serial communications. For example, if you want to connect to 4 or 5 VSD, which is definitely fine, but don't go for too many devices like 10 or 20 devices. The challenge is serial communication speed and PLC's memory limitation, please be aware of it. If you are looking for fast speed, motion control, Modbus RTU communications is not a good solution. You might think about EtherCAT, Ethernet/IP, etc. Industrial Ethernet solutions. Industrial Ethernet solutions are far away better and faster than Modbus RTU serial communications. But in cost-wise, Modbus RTU communications is the most economic way to carry out the network communications. It is free of charge, no need extra to purchase network comms cards like Ethernet/IP, EtherCAT, Profinet etc. industrial networks. Okay, let's take a look at PLC port settings. First thing first, it is necessary to configure the PLC serial comms port, port 2. So we set as following. Baud rate, 115.2 kbps. Format, 8:1, even. Mode, Modbus RTU Simple Master. Also, in the startup CPU settings, change retry counts to 2. The last thing is to transfer the port 2 settings to the PLC. For CP series micro PLCs, it is always necessary to turn the PLC power off, and back on, make sure all of PLC setting take effect. Okay, let's take a look at how to make PLC program. Please note, since Omron released new CP2W series option board, also released new function blocks that we are using today. In the new function block, just break down the serial port into 3 different communications. Port 1. Port X, which means CP2W series option board second port communications, please be aware of it. You must match up the hardware and software settings. Port 2 is purely for CP1WCIF01, CP1WCIF11, CP1WCIF12, you can't use CP2W option board on port 2. In this video, we are using option board on port 2. Please note, function blocks P1 and P1X are purely designed for port 1. Function blocks P2 are purely designed for port 2. Please make sure to use the correct function block in your PLC program. Please also be aware, not using the certain PLC memory areas in your PLC program, these certain memory areas have been occupied by function blocks, so please leave it blank, don't double use them in the program. In this example, we are using option board on port 2, so we need to use P2 series function blocks to carry out the Modbus RTU communications. Please note, all of these function blocks are purely designed for CP2E series PLC, you cannot use them in CP1L, CP1E, CP1H, and so on. In the past, if you want to implement the Modbus serial communications, it is necessary to design the control sequence inside the PLC program. New CP2E Modbus function blocks are no longer need to add extra code for command sequence control. It does automatically send/receive the Modbus command, you can just freely use them in your program, it is fine. In this example, we are using function 3, 5, 6, 3 different function blocks to control and monitor the 3G3MX2 VSD. Using send Modbus function 6 function block to write frequency to 3G3MX2 VSD. Using function 5 write single coil function block to enable VSD run. The same method, using function 5 write single coil function block to stop VSD. Lastly, using function 03 function block to monitor the VSD output frequency. Please note, I will attach example programs, function blocks, PDF tech note for subscribers download. You use this following error code list to do fault finding. For example, if you keep getting error code 0088, which means you forgot to set up the dip switches for CP1WCIF11 option board. Once finished PLC settings and program, it is also necessary to set up the 3G3MX2 VSD. In this example, we set up Modbus unit slave address 3, the default is 1, so it is necessary to change it accordingly, otherwise you will not be able to use CX Drive software to go online with MX2 VSD. A 001, frequency reference, if it is set as 3, which means Modbus comms is used. A 002, run command reference, if it is set as 3, which means Modbus comms is used. C071, 10, means highest speed, 115.2 kbps, please use shield cabling, otherwise you won't reach to this speed. C072, MODA slave station number, it is important to write this number because you need to use this number in the PLC program. C074, 1, even parity must be exactly the same as PLC serial port settings. C075, 1, stop bit, must be exactly the same as PLC serial port settings. Two more parameters settings. C076, 2. C102, 3. It is necessary to recycle the VSD power to make sure all of parameters settings take effect. As you can see, MX2 VSD is fully controlled by CP2E PLC via the Modbus RTU network. Use Modbus RTU to control the speed setup. Use Modbus RTU to control the VSD start and stop. In conclusion, CP2E's simple Modbus RTU master function is definitely a simple and economical solution for machine builders, OEM customers, water industry pump control, etc. Just one thing I'd like to mention, Modbus serial communications is still quite slow-speed communications method, so please don't use it for high-speed control or any external slave devices with more than 5 devices. Please be aware that the highest speed for Modbus is 115 kbps, but it is still much slower than industrial Ethernet solutions. If you are looking for reliable, high-speed, big number VSD control, even up to 100 VSDs, please consider using industrial Ethernet solutions, such as EtherCAT, Ethernet IP, Profinet, and so on. Please comment if you want to see the following training tutorial. I am planning to make another one, which shows how to use NX1P2 or NX102 PLCs to connect to MX2 or RX2 VSD via Modbus serial communications. Please give me feedback if you want to see more training contents on Modbus serial communications. Much appreciated. Thanks for watching my videos. If you want to receive more useful training videos, please subscribe to my channel.